Hi guys. So far we've gone over transverse waves and longitudinal waves. Okay? With transverse waves, the particles vibrate up and down. All right? So if your hand were shaking a rope, the particles of the rope would be up and down. They'd be going up and down like this. They'd be making a wave. Okay? And this wave would travel away from your hand. So the wave would be going this way. All right? And the particles would be moving perpendicularly to the wave. Now, when I say perpendicular, think this. All right? So the wave is moving this way, and the particles are moving up and down. All right? So that's what I mean by perpendicular. All right? So when transverse waves go through a medium, they move perpendicularly to the particles of that medium. Okay? And then we have another form of a wave called a longitudinal wave. All right, longitudinal waves travel parallel. All right, the particles of the wave travel parallel to the motion of the wave. So if I had like a spring in my hand and it were attached to a doorknob over here and I went boom, 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 well, there would be waves going from my hand to the doorknob. And those waves are shown in this sort of dark compressed area right here. All right, so these waves travel from the hand to the doorknob in that direction. And the wave particles are traveling in the same direction, so we say parallel. The wave particles are traveling parallel to the direction of the wave. All right, when we say parallel, it looks like this. This hand is parallel to that hand. All right, so the wave's motion is going that way, and the particles are going that way. So when you think of a longitudinal wave, you say that the particles, they go parallel, or they run parallel to the motion of the wave. All right. Another thing I want to point out is some of the terms that you use to identify parts of a wave. All right, with a transverse wave here, transverse waves, you can identify the amplitude. All right, the amplitude is just the furthest distance from the resting point. So just give me a second. I'm going to draw a line here. All right, so this isn't perfect, but I don't have a ruler, so it's not perfect, but this line here should be completely flat, and that represents the resting point. If this wave weren't going up and down, it would be completely flat at rest. And so the amplitude is just the furthest distance from the resting point to the top of the wave or to the bottom of the wave. We call this a crest, and we call this a trough down here. So the amplitude right here, the furthest distance from rest to the crest of the wave is called the amplitude, and the furthest distance from the resting point of the wave to the trough of the wave is also called the amplitude. Now these spaces should be equal. I didn't draw a perfect line. Ideally I would have drawn the line a little higher here, but that illustrates the amplitude. And the key thing that you just have to remember, even though this isn't perfectly drawn, is that the amplitude represents the furthest distance from resting point. So where my pin's running along right here, that's the amplitude. There's an amplitude there, there's an amplitude there, there's the amplitude right here. Okay, that's the amplitude. And then the wavelength is the distance for transverse waves. It's the distance between either two crests or two troughs, all right? So the wavelength in this case would run from here to there. That's one wavelength. Or you could say it runs from here to there. That's a wavelength, okay? So it's either from crest to crest, the distance from crest to crest, or the distance from trough to trough. With longitudinal waves, it can be the distance between the 2 points that are compressed. So this is one wavelength from this dark spot to that dark spot, that's one wavelength. Or it can be the distance between 2 expanded points. So that there's the start of the wavelength, and it would end right there. Okay, so wavelengths and amplitudes, and the wavelength and the amplitude tells you certain characteristics of the wave. If you have a transverse wave with a large amplitude, well, that wave has more energy. All right, and this makes sense if you could imagine a wave that's going up and down with a high amplitude, it would have a lot of energy, just like an earthquake. Imagine the land going up and down, really high and then really low. That'd be a really powerful earthquake. So the larger the amplitude, the more energy the wave has. Anyways, it looks like I'm out of recording time. So I'm going to stop the video now.